Look up at the night sky, and you'll see it. A tiny ember, glowing softly against the black. Ancient stargazers called it the god of war. Modern science calls it the red planet. But why is Mars red? And what does that color really mean? Tonight, we're not just answering a question. We're taking a slow, quiet journey to another world, letting the science of Mars lull us into wonder, and maybe even into sleep. This is the thoughtful night, where the universe becomes a bedtime story. If you're new here, take a moment to subscribe. It helps this little corner of calm science grow. And leave a comment to tell me where in the world you're watching from. Under the same sky, we're all travelers together. So close your eyes if you like. Let the day fall away. Picture yourself far above the Earth, drifting in silence, as our blue planet fades into darkness. Ahead, a pale red spark grows brighter. At first it seems just a star, but as you draw closer, it swells into a waiting world. Cold, silent, dusty. A planet glowing like an ember that never dies out. For thousands of years, humans have stared at this reddish wanderer. Babylonian priests read omens in its hue. Roman soldiers believed it belonged to Mars, their god of battle. In China, astronomers called it the fire star. Across cultures, its color spoke of blood, of danger, of divine warning. But was it always red? And is that redness a sign of war, or just a sign of time? We know now that Mars is not a star at all, but a desert planet smaller than Earth. Its surface is covered in fine, rusty dust that reflects sunlight in shades of crimson and ochre. But that's only the surface of the mystery. What made this entire world turn to rust? Where did the iron come from? Where did the oxygen come from? And what does Mars' story tell us about our own fragile home? Tonight, we'll follow that question layer by layer, like peeling back the pages of an ancient book written in dust. We'll trace the planet's past, its rivers and storms, its vanished oceans, its silent sky. We'll meet the rovers crawling patiently across its red plains. And as we learn, we'll also rest, because every scientific truth has its own quiet poetry. Imagine your ship gliding closer. The sunlight strikes your window. The planet below glows faintly, not bright like Earth, but soft and muted, like powdered brick. Swirls of dust drift high into the thin, pink sky. Shadows of old riverbeds wind across empty plains. And the question whispers again, why is Mars red? To answer it, we'll wander back in time, to when Mars had lakes, to when it had air, to when iron on its surface first met oxygen and turned to rust. And we'll see how the sun, the wind, and billions of years of silence painted this desert world the color of memory. So take a deep breath. Let this quiet hour be yours. By the end of this journey, you'll know why Mars glows like an ember in the night. But more than that, you'll feel its story, and perhaps see our own planet differently. Now, drift closer. The red planet is waiting. Long before telescopes, before rockets, before even the thought of machines leaving Earth, there was the naked human eye and the quiet sky. At dusk, when darkness settled over river valleys and desert plains, people looked upward and noticed something strange. A wandering star that gleamed not white or gold, but red. Its hue was unmistakable, a soft ember among glittering diamonds. In Mesopotamia, priests stood on ziggurats and tracked its restless path. To the Babylonians, this reddish light meant more than astronomy. It was an omen, a sign that heaven itself was watching earthly kings. In Rome, it carried the name of their god of war, Mars, who strode across the night as though searching for battlefields. Farther east in China, careful astronomers marked it as the fire star, its glow a warning of unrest. Wherever human eyes found it, the red planet was never just another point of light. It pulsed in human imagination like blood in a vein. Unlike the steady stars, it wandered, gliding against the fixed constellations. Its color set it apart. Venus shone brilliant white, Jupiter gleamed pale gold, Saturn glimmered faintly, but this one burned with a soft, steady rust. Even without understanding, our ancestors knew it was different. Fear followed that glow. If the gods wrote messages in the sky, Surely a crimson spark was not a kind word. Kings prepared for wars they hadn't planned. Generals marched to battles they hadn't chosen. And farmers prayed their harvests would survive whatever the heavens had promised. Mars, the restless wanderer, became a symbol of bloodshed long before anyone knew it was a world at all. Yet curiosity lived alongside fear. The same people who trembled at its warning also mapped its motion with patient care. They measured its backward loops, its strange retrograde dance, wondering why it defied the perfect circles of the stars. Something in that red spark whispered that it held secrets. Not just divine anger, but knowledge. Centuries passed. Telescopes revealed it was not a star, but a planet. Still, its color begged for explanation. Why would a distant world glow this way? The human eye, so quick to notice difference, lingered on that faint blush. Astronomers scribbled notes in candlelight, debating whether the hue meant deserts, vegetation, or even cities. The red planet became a canvas for hope and fear alike. But the truth of its color is not written in omens or legends. It lies in the soil itself, in dust so fine it coats the entire planet like a veil. To find out why, we must descend from the night sky and step onto that lonely ground. We must leave behind the temples and palaces of Earth, drift past the clouds of home, and land softly where no air carries a sound. Mars awaits, a cold, silent desert glowing faintly under the sun. What is this redness really made of? We must land softly on its dusty ground. The land beneath your feet is silent. No wind roars in your ears. No birds call in the dawn. No water runs in the valleys. Mars is a world stripped bare, a cold desert under a thin, fragile sky. Its air is barely there, less than 1% the thickness of Earth's atmosphere, and too weak to hold warmth or moisture. When night falls, the temperature plummets. When day comes, the sun's light is sharp but powerless to heat the ground. Everywhere you look, dust drapes the land like a faded cloak. This is not the coarse sand of an earthly desert, heavy enough to stay put. Martian dust is lighter than talcum powder, so fine that it clings to everything. It lifts easily in weak gusts, swirling into the thin air and settling again like rust-colored snow. The planet's surface is covered by this endless veil, hiding the bedrock beneath. At dawn, the horizon glows soft pink, as if lit by a distant candle. When the sun rises, it casts a pale amber light over plains that stretch for hundreds of miles, unbroken by trees or rivers. Hills rise like sleeping giants. Craters yawn wide and silent. The ground itself is tinted red, not bright like blood, but muted, like iron left out in the rain and forgotten for centuries. Scientists studying this barren landscape through spacecraft and rover cameras learned something remarkable. Nearly all of this dust contains iron. The grains are made of minerals rich in that familiar metal, the same element forged in the hearts of ancient stars, the same element that runs in your blood. On Earth, iron hides deep in rocks, soil, and even within us. But here, it lies exposed, unprotected. That exposure is the secret to Mars' color. Over billions of years, the iron in these rocks reacted with tiny traces of oxygen, transforming into iron oxide, rust. Every storm that sweeps across this dry world grinds rock into dust and spreads that rust like paint across its entire face. From space, the planet glows like a faded ember, a single hue unbroken by forests, oceans, or cities. Stand still for a moment. Look at the ground beneath you in your mind's eye. Each particle of dust tells a story older than Earth's mountains. Once, long ago, this planet may have been gray, dark, or even black with fresh volcanic rock. But time wore it down grain by grain, and as the surface weathered, it changed color. The result is not just a red planet, but a planet of dust, fine, dry, restless, waiting for wind to carry it across endless plains. Even in its stillness, Mars breathes in a quiet rhythm. Small whirlwinds called dust devils creep across the surface, lifting this fine powder into the air. Global storms, lasting weeks, can wrap the entire planet in a haze, turning it into a glowing red marble scene from Earth. These storms are not violent like hurricanes. They are soft, slow-moving veils. Yet they carry enough dust to blanket continents, enough to remind every machine that lands here that Mars is alive in its own silent way. The colors shift gently under the sun. In some places, the ground glows bright orange. In others, especially where bedrock peeks through, it deepens to brown or purple red. From the deck of a rover, the view feels endless. An ocean without water, a desert without sound. The thin Martian air cannot shield the surface from space. There is no rain to wash the ground clean, no rivers to carry dust to the sea. What falls stays. What is ground to powder remains powder forever. This is why the planet looks the same from every direction, why its rusty tone does not fade with the seasons. You could pick up a handful of this dust and let it slip through your fingers like red smoke. In it lies the memory of volcanoes that once roared, of ancient mountains ground down to sand, of rocks shattered by impacts from falling meteors. It is the residue of a planet's long, slow breathing, a breath that now barely stirs. Mars is not just red by chance. It is red because time has had its way with it. The dust tells us that this is an old world, a world where change happens slowly, without oceans to erase the past. It is a mirror of what Earth might look like if stripped of its water and life. Iron, this simple, familiar element, is everywhere on Mars. But how did it come to cover an entire planet? What made the red planet such a perfect canvas for rust? To answer that, we need to look deeper than dust, down into the bedrock, into the crust where this iron was born. Iron, a metal we know so well on Earth. But how did it paint a whole planet red? Beneath the thin veil of dust, Mars is a planet built from ancient rock laced with iron. This iron was not placed there by chance. It was forged long before Mars itself was born, in the fiery hearts of giant stars that lived and died billions of years ago. When those stars exploded, they scattered their heavy elements across the galaxy. From this cosmic ash, planets formed, ours included. Mars inherited a generous share of iron, locked inside its crust and mantle. On Earth, much of our iron sank deep into the planet's core, drawn inward by gravity when our world was young and molten. But not all of it. Some remained mixed in surface rocks, hidden beneath forests and oceans. Over time, plate tectonics and flowing water kept Earth's iron cycling, burying it, melting it, and remaking it again and again. Mars followed a different path. Smaller and colder, it lost its internal heat more quickly. Without strong plate tectonics to recycle the crust, the iron stayed at the surface, waiting patiently to meet oxygen. The planet became a museum of minerals, unchanging, unprotected, and perfectly positioned to weather into rust. If you could wander across the Martian highlands, you'd find basalt, the dark volcanic rock also common on Earth. But here it lies exposed, broken down over eons into fine particles. In these rocks, iron is a silent passenger. When fragments cracked and crumbled, their iron-rich minerals met the elements, even in small amounts, and transformed. The result is a surface carpeted in iron oxide, the mineral that gives the planet its ruddy complexion. Rust is a familiar thing on Earth. Leave an iron tool outside, and the air and rain will corrode it quickly. But on Mars, where rain never falls and air is thin, oxidation happens differently. Instead of fast decay, it is a slow whisper, a chemical exchange taking place grain by grain, over millions of years. The Martian dust is not a deep red, but a soft, muted rust, the shade of old brick or dried clay. Imagine kneeling beside a rover as it digs into the soil. Beneath the first layer of powder, the color hardly changes. The iron is not just sprinkled on top like paint. It is built into the crust itself, present in the very bones of the planet. Wherever you look, the rocks speak of an iron-rich past, one that shaped Mars long before any windstorm could carry its dust skyward. Earth has iron, too. In fact, it's the reason your blood is red. Hemoglobin carries oxygen on tiny iron atoms inside every cell. But Earth's surface is alive with water, plants, and oxygen-rich air. Rust never lasts long here. It flakes off, washes away, or gets buried and remade. Mars lacks these cycles. What turns red stays red. Time does not erase the evidence. So when you gaze at Mars through a telescope and see its soft crimson glow, You are looking at an ancient surface that hasn't been renewed in billions of years. You are seeing the steady accumulation of iron oxide, layer upon layer, like pages in a book that has never been turned. But this raises a puzzle. Oxidation needs oxygen, and Mars has almost none today. Where did that oxygen come from long ago? Was it locked in the rocks themselves? Did it flow once in the air or ride in the water that carved old valleys? The answer lies in Mars' early history, when the planet was warmer, wetter, and far more dynamic. To understand its red coat fully, we must imagine a time when Mars was not so silent. A world with lakes and rivers, clouds and storms, where oxygen could react freely with iron. But oxidation needs air, and Mars has almost none. So where did all that oxygen come from? Picture Mars not as the cold desert you've just walked across in your imagination, but as it might have looked billions of years ago. The air was thicker then, pressing gently against the ground. Clouds drifted across the sky. Rivers traced silver lines through dark valleys, pooling into wide lakes that glittered in the pale sun. Mars was not always a dry world. It once carried the sound of flowing water. That ancient air held something precious. Oxygen, though not as much as Earth's atmosphere today. It came from volcanic eruptions, chemical reactions, and sunlight splitting water vapor in the upper sky. For a time, Mars had the ingredients needed for iron to rust on a planetary scale. Iron in its rocks, oxygen in its air, and water moving freely across its surface. Follow those rivers in your mind. Watch as they wear down the rocks, breaking them apart grain by grain. As fresh surfaces of basalt are exposed, the iron inside them meets oxygen and water together. The reaction is slow, but relentless. Black volcanic minerals turn to soft reddish-brown oxides. Every flood, every rainstorm, every trickling stream leaves behind a stain. This is how the planet began to change its face. When lakes filled and then evaporated, they left crusty mineral beds behind. When rivers carved their way through hills, they deposited layers of iron-rich sediment across the lowlands. And when ancient oceans, if they truly existed, slowly disappeared, they revealed vast plains ready to be scoured by wind. Over time, the surface became coated with rust-colored dust that spread like a desert sunrise. But this period of warmth and wetness didn't last. Mars was too small to hold its atmosphere forever. Without a strong magnetic field to protect it, solar winds stripped away the air. The pressure dropped, the clouds vanished, and the rivers froze or seeped underground. As water disappeared from the surface, oxidation slowed, but the red coating was already there, locked in place like paint that never peels. Imagine standing in a shallow Martian lake 3 billion years ago. The water is cold but not frozen. Fine sediments swirl around your ankles as you move. Those sediments contain iron, and as they settle, they take on a rusty tinge. Above you, the sky is dim but not empty, thin sunlight filtering through a dusty, oxygen-poor atmosphere. This is when Mars' surface received its deepest stains, when air and water worked together to transform a volcanic planet into one that blushed permanently red. Even after the water vanished, traces of its presence remained. Rover missions have found mineral clues, hematite, jarosite, and other iron oxides that only form in the presence of liquid water. These are chemical fingerprints, silent witnesses to an earlier time. They tell us that Mars' redness is not just the result of dry weathering, but of a world that once had the chemistry of rivers and rain. Earth's landscapes constantly erase themselves. Our mountains rise and fall, our oceans shift and recycle the crust. But Mars preserves its history in plain sight. Its rusty plains are not a passing phase. They are a fossilized memory of a wetter world. Each dust grain is a time capsule holding evidence of air and water long gone. The irony is gentle but profound. The same elements that make life possible, air and water, also gave Mars its lifeless red surface. They worked their slow alchemy, turning dark iron minerals into iron oxides, and then they left, blown away by the solar wind, frozen into polar caps, or locked deep beneath the soil. Now Mars stands silent, a frozen monument to what it once was. Its rusty color is both a story of change and a reminder of loss. When we gaze at its soft glow, We are looking at a planet marked forever by its vanished rivers and its vanished breath. Yet water and air are only part of the tale. Even after the atmosphere fled, something else continued to shape Mars' surface. Something harsher, older, and more patient than weather. To complete this picture, we must leave behind flowing rivers and drifting clouds, and step into the realm of space itself, where the sun and the stars have been painting Mars for billions of years. But there's more to this color than water and air. Space itself is painting Mars too. You have traveled far in your thoughts already, following dust storms that circle Mars like silent dancers. Yet the mystery is not finished. For to understand why the planet glows rusty red, you must follow the wind itself, and the way it sculpts every grain of soil, every pebble, every lonely boulder lying in the cold Martian sun. On Earth, weathering comes with rain and running water, with forests that hold soil together and rivers that carry it away. On Mars, no such comfort exists. There is almost no rain, no rivers, no oceans to cradle the land. And yet the rocks crumble, the hills turn to powder, the mountains wear down just as surely as mountains here at home. The culprit is cosmic weathering, a slow, invisible hand reaching down from space. Tiny meteoroids, no larger than grains of sand, strike the surface with the gentlest of taps. Over billions of years, those taps add up. Solar wind streams pass the planet unshielded, bombarding exposed soil with particles so small you could never see them, yet powerful enough to rearrange atoms. Micrometeorites kiss the ground and shatter it into pieces finer than dust. Picture yourself standing there, on a ridge above Valles Marineris. The sky is butterscotch, thin and cold. A single gust picks up grit from the slope and whirls it around you. Every grain has been beaten by radiation, chipped by impacts, rusted by whispers of oxygen long ago released from ice and rock. As this dust swirls, it does not fall into rivers or gather in puddles. It stays, coats everything, blankets the surface with a thin, iron-rich veil. The wind on Mars can be slow as breath or fierce as a global storm. In gentle times, it polishes rocks until they gleam like glass. In wilder seasons, it can sweep across entire hemispheres, lifting dust high into the atmosphere. That dust is not clean. It is stained with iron oxides, the chemical rust that gives the whole planet its reddish hue. Each storm spreads this color like paint brushed by an invisible hand, evening out the tones, leaving no region untouched for long. Close your eyes and imagine it. A place where weather is not shaped by water, but by light and impact, by the constant drizzle of cosmic particles. On Mars, day after day, ultraviolet radiation from the sun breaks apart molecules in the soil. Hydrogen drifts away into space. Oxygen lingers, meeting exposed iron to form oxides. Tiny coatings of rust that darken and deepen with every century. No single event paints Mars red. It is the sum of countless small moments, each one almost too subtle to notice. A micrometeorite hits and vaporizes in an instant. A solar particle blasts a grain of sand, knocking loose an electron. A gust of thin air drags that grain up a slope and drops it miles away. Add millions of years, and what do you see? A planet cloaked in soft, even color, as if it has been dusted with the ashes of time itself. Scientists call this space weathering. Though there are no clouds, no rain. It is a slow cosmic alchemy, one that has touched every airless or thin-aired world we know. The moon, Mercury, asteroids drifting silently in the void. But on Mars, the process is painted in warm, rusty tones, made rich by the planet's hidden iron heart. Perhaps this is why Mars looks so alive even though it is barren. Its color breathes. Its hue changes subtly with the seasons. It reflects storms you cannot hear and winds you cannot feel from Earth. You are seeing not just a planet, but a story told grain by grain, layer by layer, a tale of cosmic patience. If you let your thoughts wander now, you might imagine being a single speck of Martian dust, lifted high above the canyons, glowing faintly red in the sunlight as you drift across the equator. You settle on an ancient rock, covering it with your thin, rusty skin. The next storm will carry you away again. And in this endless cycle of lifting, settling, and rusting, the whole planet keeps its blush. Long before humans built telescopes, long before your ancestors wondered at that fiery point of light in the sky, this weathering was at work. It is patient. It does not hurry. And so Mars remains what it has always been. A place shaped not by oceans, but by the quiet breath of space itself. As the chapter closes, feel yourself floating above this silent world. No sound of rain, no rivers carving valleys. Only dust, only time, only the wind, and the unbroken red cloak that spreads from pole to pole. The first time Mars was truly seen by human eyes, it wasn't through a spaceship window, it was through a thin glass lens. Imagine Galileo, in the year 1609, lifting his crude telescope toward the night sky. The device could barely magnify, yet there it was, a tiny, wandering star tinged faintly red. He didn't see deserts or mountains, just a shimmering disk no bigger than a pinhead. Still, it was enough to plant a question deep in humanity's mind. What is this distant world? Centuries later, better telescopes came, and so did sharper eyes. In the late 1800s, Italian astronomer Giovanni Schiaparelli traced dark lines across the Martian globe. He called them canali, channels, but when the word was translated into English, it became canals, as if Mars were laced with engineered waterways. The world imagined Martians digging vast irrigation systems. Newspapers speculated, novels bloomed. A red planet became a place of mystery, industry, even civilization. But the truth would wait until we could leave Earth entirely. In the 1960s, spacecraft began to slip the bonds of gravity. Mariner 4 was first to fly by Mars in 1965, sending back blurry photographs that broke humanity's heart. No canals, no glittering cities, just a cratered, empty land, silent as stone. Later mariners, Vikings, and orbiters traced coastlines of long-vanished rivers, but still no life stirred. We learned that Mars had been cold and dry for ages, its surface scoured by dust storms that raged for months, its atmosphere thin as breath. Then came the rovers, small machines yet alive with purpose. Spirit and Opportunity rolled down ramps in 2004, twin explorers on opposite sides of the planet. They found evidence of ancient water locked in rocks. Curiosity followed in 2012, a car-sized laboratory humming softly as it climbed Mount Sharp, its wheels crunching the iron-rich soil. Today, Perseverance roams Jezero Crater, listening for whispers of long-dead microbes, its tiny companion drone, Ingenuity, buzzing briefly into the thin Martian air. Close your eyes for a moment and hear it. Not the roar of rockets or the chatter of mission control, but the gentle purr of wheels turning on rusty ground. A sound so soft it could almost be mistaken for the Earth breathing. Every image these explorers send home strips away another layer of myth. No canals, no towering civilizations, just rock and dust and a silence deeper than any desert on Earth. And yet, in that silence, there is beauty, ancient beauty, written in iron and sand. The closer we look, the more we learn, not just about Mars but about Earth too. Because in its rust, in its frozen rivers, Mars is a mirror showing what happens when a world grows still, and when time leaves its mark. Beneath your feet, deep below the quiet soil and solid rock, Earth's heart beats with molten metal. A vast core of iron and nickel spins like a glowing ember, churning, restless, alive. It powers our planet's magnetic shield, protects our atmosphere, and keeps our surface warm and welcoming. Mars, too, once had such a heart, but now it lies still, cold, and silent. Imagine both worlds in their youth, glowing with heat from their violent birth. Both were seeded with iron, the same cosmic gift left behind by dying stars, scattered across the solar system like sparks from a fire. In this, Earth and Mars are siblings. They were forged from the same ashes, built from the same stardust. You carry that legacy, too. Every drop of blood in your body glows faintly red because of iron, the same element that paints the deserts of Mars. In a way, you already carry Mars inside you. But why is Earth so full of life and color, while Mars has faded to rust? The difference lies in the beating of their planetary hearts. Mars cooled too quickly. Its smaller size allowed its inner fires to die out. The iron in its core solidified and froze, its magnetic field vanished, and its thin atmosphere was stripped away by the solar wind. Exposed to space, Mars could not keep its water. Ancient rivers and lakes dried into dusty scars. The world reddened as its unprotected iron minerals turned to rust beneath the faint sunlight. Earth took another path. Our planet's core stayed molten, its protective magnetic cocoon holding strong. Oceans pooled and stayed full. Rain fell and flowed, carving valleys and nourishing life. The same iron that glows red on Mars is also here on Earth, but our world never turned into one great desert. Why? Because Earth recycles. Rain wears down rock, rivers carry it to the sea, and deep inside the planet, tectonic plates sink and rise again, melting and remaking the surface. Iron here does not sit exposed for billions of years, quietly rusting away. It is buried, reborn, reshaped. Mars, with no such renewal, kept its rust on the surface, a permanent reminder of time's patient hand. Pause for a moment. Feel your own heartbeat. With every pulse, iron in your blood ferries oxygen through your body, keeping you alive. In a distant echo, Mars' iron lies scattered in its dust, lifeless and still. Same element, same origin, but one world beats and the other slumbers. Earth and Mars tell the same cosmic story but with different endings. Their iron came from ancient stars, from explosions so fierce they forged metals in their dying breaths. Those stars scattered iron across space into asteroids, into planets, and finally into you. When you look at the red dust of Mars through a telescope or from the cameras of a passing rover, you are looking at your own ancestry written in the color of a faraway desert. Mars is a mirror. It shows us what can happen when a world falls silent. Without oceans, without a living biosphere, without a core that stirs the crust, a planet grows still and dry. The skin fades from vibrant rock to endless rust. Earth could have been the same, but it isn't. Not yet. Our planet hums with life, cycles, storms, breath. Mars reminds us not to take that heartbeat for granted. And yet, there is a quiet beauty in Mars' stillness. No storms of tectonic fire tear at its crust. No roaring oceans reshape its surface. Time there is slow, unbroken, almost peaceful. The red is not just a warning of death. It is a sign of patience, of endurance, of a planet that has simply grown quiet with age. So when you gaze at Mars, whether through the eye of a telescope or the silent lens of a rover, remember, you are seeing a sibling's face. One that shows you both your shared origin and your different fate. You carry iron in your veins. Mars carries it in its dust. You are, in some way, already connected. The closer we look, the more we learn, not just about Mars, but about Earth too. Beneath your feet, deep below the crust and mantle, Earth holds a glowing heart. Its core is a restless ocean of molten iron and nickel, churning slowly, powering the magnetic field that shields our fragile biosphere. That living heartbeat is the reason your compass points north, the reason cosmic winds don't strip our air away. Mars once had such a heart, too. Long ago, its iron core swirled and pulsed, a molten engine like Earth's. But then, something happened. The smaller planet cooled faster, its inner heat leaking into space. Its core froze, and its magnetic shield faded. Without that invisible protection, solar winds swept across the Martian skies, stealing its atmosphere molecule by molecule, leaving behind a world unguarded. And so, as the eons passed, the iron in its soil met the whisper of thin air and the trickle of ancient water, and rust bloomed across the planet. The great red desert we see today is the silent echo of a lost heartbeat. Now turn that thought inward to yourself. In every drop of your blood is iron, born from stars long dead. The same element that stains Mars with rust is the element that lets your blood breathe. Each hemoglobin molecule holds iron at its center, cradling oxygen as it moves through your body. When you inhale, you are doing what Mars no longer can. You are letting iron carry life. You carry Mars inside you. It's a quiet truth, but a profound one. Earth and Mars are siblings in metal and stone, forged from the same cosmic dust. But their fates diverged. Why didn't Earth turn red like Mars? The answer lies in water, in air, and in life itself. On Earth, iron rarely lies still. Rain washes it from the land into rivers and seas. Plants and microbes lock it away, transform it, pass it through countless living hands. The oceans breathe iron in and out, recycling it again and again, never letting it simply sit and rust untouched. Even the rocks of our continents are reshaped by plate tectonics, buried and reborn in fiery cycles. Mars, without oceans, without forests, without that slow-beating heart, had no such recycling. The iron at its surface simply waited for air and water to caress it, and then turned to dust. A single unbroken breath of oxidation, stretched over billions of years. Stand, for a moment in your mind between the two worlds. Feel Earth beneath your feet, humming faintly, magnetic field wrapping you like an invisible cloak. Then picture Mars, silent and exposed, its red sands blowing freely under a pale sun. Both worlds are mirrors, reflecting what iron can become in different fates. Here, the red element moves through living veins. There, it drifts lifeless across a barren plain. When you gaze at Mars through a telescope, you're not just looking at a planet. You're looking at a reminder. Earth is alive because its interior still burns, because oceans still stir, because life never lets the iron sleep too long. Mars is what happens when the music stops, when a planet cools, when silence settles over stone. Mars shows us not only what it is, but what we might one day become if Earth's own heart slows and its protective breath fades. In its quiet way, the red planet is whispering, "Worlds do not live forever. Take care of yours while it still beats." And yet, this isn't only a warning. It's a link, a bond of shared ancestry written in metal. The rust on Mars and the iron in your veins were forged in the same kind of ancient star. When that star died, it scattered its elements across space. Some of that dust became Earth. Some became Mars. Some somehow became you. Think of that when you see the red planet glimmer in the night sky. Its color is not distant or foreign. It is family. You carry its story, atom by atom, through every breath. The closer we look, the more we learn, not just about Mars but about Earth too. Imagine rewinding the clock on Mars, billions of years into the past. The red dust has not yet coated every hill and hollow. The planet is wetter, warmer, alive with rivers running through young valleys. Lakes glimmer beneath a softer sky, and clouds gather like veils drawn across a newborn sun. If you stood there, then what color would Mars have been? Would it have glowed red, as it does now, or might it have been blue, green, even golden? Let's play this thought experiment carefully, like an artist with a fresh canvas. The rust we see today, iron oxide born of air and ancient water, is not inevitable. If Mars had held on to its oceans, if it had clung to a thick atmosphere, the story written in its soil could have taken a different hue. Iron itself is a chameleon. Its chemistry dances with the world around it. In Earth's deep seas, iron hides as gray or black minerals, shielded from oxygen by blankets of water. In Mars' lost rivers, perhaps it once did the same. Picture a wetter Mars draped not in red, but in earth tones. When iron stays locked away, other minerals step into view. Pale clays, golden sulfates, dark volcanic basalt. Imagine coastlines edged in green, not by forests. Mars was never that alive, but by faint blooms of microscopic life, if such life ever took hold. Even without life, minerals alone can paint a planet. Copper oxides could lend turquoise shades. Sulfates might brighten the soil to yellow-white. Silica, washed by ancient waters, could turn valleys pale as chalk. And what about the sky above? A denser atmosphere could have scattered sunlight differently. With more air, dust would have been heavier, harder to loft, leaving the heavens clearer. Carbon dioxide and water vapor would have made the sunsets soft and golden rather than harsh and rust-red. Mars might not have been a desert world at all. It might have looked, at least from orbit, as gentle and muted as Earth's own high deserts, with streaks of green-gray rock and blue ice at the poles. But history chose another path. The planet cooled. This magnetic field faded. Solar wind stripped away much of its air, and water escaped or froze. In this new, thin-breathed world, iron met oxygen in a slow, unending reaction. Grain by grain, dust by dust, Mars turned red. The color we see today is not a signal of life, but of its absence. Red on Earth is often vibrant, blood, flowers, autumn leaves, the pulse of something alive. On Mars, red is quiet. It's the silence left when water goes away. Still, the what-if lingers. Could Mars have been blue? Could it have been green? The answer lies in chemistry, not fantasy. Iron can stay dark if buried under oceans, unexposed to air. Basaltic plains can stay black. Sulfates can bleach landscapes pale. Even now, rovers see patches of Mars that are not red. Gray rocks freshly broken open, white salts crusting over dry lake beds, black sand blown into ripples. If you stripped off the oxidized surface, Mars would not be red at all. It would be as gray and dark as any volcanic world. What if, instead of drying, Mars had stayed wet? Its rivers would have run for millions of years longer, leaching minerals, rearranging colors. Hydrothermal vents might have spread dark, metallic hues, while carbonate deposits could have left pale green layers on the floors of vanished seas. Perhaps shallow waters would have glowed bluish-green from sunlight scattering off fine particles, an echo of our own tropical shallows, though with no fish darting through them, no coral building bright reefs. Mars could have looked peaceful, almost Earth-like, yet eerily still. Even now, you can trace the memory of water in its colors. Orbiters see channels carved by floods, fans where deltas once spread, deposits that only flowing streams can leave. These features are not rust-red. They are often dull and shadowed, reminders of the planet Mars used to be. Scientists study these hints like archaeologists reading faded ink on ancient parchment. The past is not lost. It is written in every valley, every stone. And this is the quiet poetry of Mars, a dead world that remembers how to look alive. Its surface, stripped of blue seas and green valleys, still holds traces of what might have been. It shows us how color is fragile, how the hue of a planet depends on breath, on water, on a shield against the relentless sun. Earth is not red because it recycles its iron. Oceans hide it. Plants lock it away. Our sky stays blue. Our soil stays brown, because life keeps rearranging the chemistry. Mars, lacking that, drifted into stillness, and the stillness turned to rust. So could Mars have been blue or green? Yes, under different conditions, chemistry could have painted it so. But the palette of a planet depends on its heartbeat. Mars stopped breathing long ago, and in that silence, red dust took over. And yet, the red is beautiful. It glows at dawn and dusk. It stretches unbroken to the horizon. Even a dead world can shine. Even rust can catch the sun and turn to gold. When you look at Mars through a telescope, remember, you're not seeing what it always was. You're seeing what it became when time, air, and water walked away. The closer we imagine its past, the more we realize that color is a kind of story. Red is not destiny. It is the last chapter of a planet's tale. What came before was more complicated, more changeable, more alive in its own quiet way. And what lies ahead, when human eyes see it up close, when human hands touch its soil, may add another chapter still. And yet, even a dead world can glow with beauty. Mars has never just been a planet. It has been a symbol, a challenge, a crimson spark in the sky that has tugged at human imagination for centuries. Long before spacecraft traced its contours and rovers pressed their wheels into its dust, Mars lived inside our stories. In Roman mythology, it was the god of war, a fitting name for a world that glows like a coal in the darkness. Ancient astronomers charted its wandering path, calling it a planet, a wanderer, because it moved against the steady backdrop of stars. When Galileo raised his telescope, Mars became more than a red speck. It became a disk, mysterious and alive, turning slowly like an ember in space. Later, Giovanni Schiaparelli drew maps and spoke of canali, channels he thought he saw cutting across the surface. In English, it became canals, a single mistranslation that gave birth to 1,000 dreams. Perhaps people thought there were engineers on Mars building waterworks to save their world. By the late 19th century, Percival Lowell filled entire books with visions of Martian civilizations, dying but noble, fighting to keep their deserts alive. These stories were not science, but they were powerful. They painted Mars as a mirror of human ambition, a distant cousin sharing our destiny. Even as later telescopes revealed that those canals were illusions, the dream did not die. It shifted shape, flowing into novels, music, cinema. From H.G. Wells' War of the Worlds to the haunting strains of Holst's The Planets, from early pulp magazines to the grand visions of Ray Bradbury, Mars became a canvas for everything we feared and everything we hoped for. The color red helped. Red is not a quiet color. It is the color of fire and blood, of warning lights and open hearts. In every culture, red stirs emotion. It signals danger, desire, passion, courage. Mars, glowing red among the stars, seemed to call to us in a language older than words. We answered not with mathematics first, but with myth. When the first robotic emissaries, Mariner, Viking, arrived in the 1960s and 70s, the truth was both humbling and breathtaking. No canals, no cities, no green forests waving in a thin Martian wind. But there were valleys as wide as continents, volcanoes taller than Mount Everest, dust storms that could swallow half a planet. Mars was dead, but not empty. It was silent, but not still. Its rusted surface carried the memory of rivers, floods, oceans long gone. The red dust clung to the wheels of spirit and opportunity, the brave twin rovers who rolled for years longer than anyone expected. Curiosity followed, humming softly across the crater floor, sniffing the thin air, tasting the rocks. Perseverance now roves a world that is no longer only a dream. Every track left in that dust is a promise, a sign that human boots may one day follow. And still, Mars is a muse. In music, it is a drumbeat of war or the lonely note of a distant horn. In film, it is a horizon waiting for settlers or a wasteland filled with ghosts. In literature, it is sometimes a new home for humanity, sometimes a warning of what happens when worlds grow cold. The color red makes it feel urgent, alive even in death. It is as though Mars has been calling to us not with its voice, but with its hue. One day, that dust will cling to a human footprint. Perhaps the first person to walk on Mars is alive right now, looking up at the night sky, dreaming. They will stand on a desert world painted red by iron and time, and they will see Earth as a pale star rising over a barren horizon. That moment will not belong to science alone. It will belong to every story, every dream, every heartbeat that has ever looked at Mars and felt something stir. The red planet lives in us as much as it lives in the sky. It is war and wonder, fear and hope, danger and desire, all glowing faintly through the thin Martian air. The closer we get, the less it feels like an alien world and the more it feels like a destination written into our history. We have already touched it with our machines. Someday we will touch it with our own hands. And when we do, the color red will no longer be just a distant light in the darkness. It will be the soil beneath our feet, soft and dusty, clinging to our boots like a memory of ancient dreams. But before we arrive, before rockets rise and habitats unfold, let's pause. Let's stand still on Earth, under our own sky, and gaze at that quiet spark of light. For Mars is not racing away from us. It waits, steady in its orbit, as though patient enough to hold our dreams a little longer. But before we arrive, let's stand still and gaze at its quiet sunset. The sun sinks low over the Martian horizon, not with a fiery blaze like on Earth, but with a strange, muted grace. Imagine standing on a rocky plain as the thin, cold air carries almost no sound, no rustle of leaves, no whisper of water, only silence. The sky dims, but instead of deepening into crimson, something unexpected happens. At the very center of the sunset, where you'd expect the sun's last rays to paint the heavens red, the light softens into an eerie blue glow, framed by pale amber edges. Feels almost impossible, doesn't it? A red planet giving birth to a blue evening. But light plays by the rules of physics, not by what we expect. The Martian dust, so fine and pervasive that it seems to live in every corner of the world, scatters sunlight differently than Earth's sky does. On our planet, nitrogen and oxygen scatter short blue wavelengths in all directions, turning daytime skies brilliant azure. But on Mars, the iron-rich dust tends to scatter red light away from the sun, leaving a soft halo of blue where the fading daylight passes straight through. So you stand there, or at least imagine yourself standing there, as the distant sun, half the size it appears from Earth, slips below the jagged edge of the horizon. The landscape glows with a quiet copper sheen, but the sky over your head blooms blue, like the memory of oceans Mars no longer has. This is a world that died of thirst, yet it paints its evenings with the color of water. You feel a kind of loneliness as you watch. No birds will ever fly through this twilight. No waves will ever break in the distance. The air is too thin to breathe, too cold to comfort. And yet, there is beauty, delicate, restrained, almost shy. Even a rusted desert world, barren and still, offers moments of soft light, as though trying to remind you that every world, no matter how dry or distant, has its own way of saying goodnight. The rust beneath your feet is iron oxide, ancient and unyielding. For billions of years it has sat here, unchanged, while Earth danced with oceans and winds, washing its own iron deep into its core or locking it into living blood. On Mars, time does not heal or recycle. Time only settles like dust, waiting. As the sun finally dips below the edge, the blue fades to gray, then to black, and the stars sharpen in the thin air. They seem closer, more piercing, like tiny windows into other worlds. The day is gone, but the planet still glows faintly under the starlight, holding its color the way an ember holds its warmth long after the fire has burned away. You think back to the question that brought you here. Why is Mars red? The answer feels clearer now, though it comes not as a fact to memorize, but as a feeling to understand. Mars is red because it is quiet, because it stopped moving, stopped changing, and let time do what it always does. Turn bright metal to rust. Water, air, and iron met here long ago and wrote their story in the dust. And that story lingers, even when no one is around to read it. But in this stillness, in this fading light, you also sense something else. Not just an explanation, but an invitation. Mars whispers that every world has its colors, and every color has its meaning. Red does not only mean death or danger. It can mean memory, endurance, and the strength to last forever. Even a lifeless planet has sunsets worth watching. Even a cold desert can surprise you with a moment of blue. Now, as night takes over the Martian plain, let the image settle in your mind. A horizon lined with copper, a fading sun ringed with sapphire, and an endless silence falling like a soft blanket. No wind to stir the dust. No sound but your own slow breath, imagined through the thin helmet of your spacesuit. Just a world at rest, and you, a quiet guest, drifting with it into darkness. And now, as you close your eyes, carry that sunset with you. Let its colors wash over you. Rust red for memory, deep blue for peace, soft gold for dreams. The sky of Mars, though far away, reminds you that even in solitude there is beauty, and even in silence there is light. Sleep now, as the stars rise over a distant desert. The sun has set on Mars, and soon it will set on your thoughts too. Let the red world cradle you in its stillness. Let the last light of day fade gently, until all that remains is rest. As Mars drifts into the dark of space behind us, its rusty glow fades to a whisper. You've walked through ancient valleys, crossed frozen rivers of iron dust, and watched the pale sun paint the horizon in colors you never expected. In the stillness, the red planet feels less like a distant world and more like a quiet reflection of ourselves. A reminder of how fragile, how precious, life can be. Let this thought stay with you. Worlds change. Water vanishes. Air thins. But wonder endures, carried by those who dare to look up and ask why. Tonight, you've been part of that timeless journey. One that stretches from Galileo's glass lens to the humming wheels of rovers on alien soil. If you'd like to keep traveling among stars and questions, stay close to this channel. Each night, we'll explore another corner of the cosmos, letting science guide us and calm storytelling carry us gently toward rest. Close your eyes now. Imagine the soft Martian dust settling, the horizon fading to blue, and the universe quietly turning. Sleep well, traveler. Your next adventure awaits among the stars.